Back in Chem 1, we talked about solubility, and we have tables of solubility rules which tells us whether or not a particular ionic compound will be soluble or insoluble. And for example, something like silver chloride, silver 1 chloride, AgCl, if you look up on the solubility rules, this is listed as insoluble. So if this were a product in a double replacement reaction, it would be a precipitate. It would precipitate out of solution. It is insoluble. It doesn't dissolve. Yada, yada, yada. We sort of lied to you. We didn't lie much, just a little bit. It is considered insoluble, but as we learned earlier in the semester, there are variations of solubility. Some things are very soluble, some things are even more soluble, some things are less soluble. If we look at the solubility curve that gave us the solubility at various temperatures, the graphs were all over the place. Well, once a substance, an ionic compound, has such a small solubility way down at the bottom of the graph, at the bottom of the curve, at the bottom of the page, we consider it insoluble. I do not know where the cutoff is. It doesn't matter where the cutoff is. Some substances are considered insoluble when technically they are only very slightly soluble rather than insoluble. And silver 1 chloride is one of these substances. Actually, if you put solid silver 1 chloride in water, it will form an equilibrium with the ions, the aqueous ions that you would expect to get if it actually did dissolve. This is an equilibrium reaction, whereas a soluble salt would simply be a forward reaction. This is an equilibrium reaction with an equilibrium constant. The equilibrium constant is products over reactants, but remember that we do not put in any solids or liquids, so this is the equilibrium constant for this reaction. For all salts that are only slightly soluble, previously known as insoluble, the only thing that shows up in the equilibrium constant are the products, which are the ions that are formed as it dissolves, and for that reason this equilibrium constant is often referred to as a solubility product constant. So the solubility product constant for silver 1 chloride has this formula, and the numerical value for this is a very small number. At 25 degrees Celsius, my table lists it as 1.8 times 10 to the minus 10, which means only a very, very, very small amount of products are present at equilibrium. 0.00123456789118. That is the product of the concentration of silver ion times chloride ion. Very, very small. In a 1-to-1 reaction, I would produce 1 silver plus 1 ion for every 1 chloride ion, so I could calculate what I would expect the concentration of Ag plus or Cl minus to be, because they'll be the same. That will equal 1.8 times 10 to the minus 10. To solve for x, take the square root of 1.8 times 10 to the minus 10, and you get that x equals 1.3 times 10 to the minus 5. That means the concentration of Ag plus, which is the concentration of Cl minus in a saturated solution of silver 1 chloride, would be 1.3 times 10 to the minus 5 molarity. A really, really small concentration, which is why before today we have simply said that silver 1 chloride is insoluble rather than slightly soluble. Well, there are instances where this becomes important, where the small amount of silver ion or chloride ion present in the presence of solid silver chloride, there are times when that's important. If, for example, you're trying to eliminate chloride ion from a particular solution because it interferes with the test or it poisons somebody, then chloride ion isn't very poisonous, but for example, then it would be very important to know exactly how much chloride ion was present, including any small amounts that were present from some insoluble substances. And so we can write this equilibrium expression for all insoluble substances. We have tables of their solubility product constants, which are the equilibrium constants for these particular equilibrium reactions. And those numerical values then can be used to determine what the solubility is. The KSP value, this is called the solubility product constant. When I solve this problem and find 1.3 times 10 to the minus fifth molarity equals the concentration of, for example, the chloride ion, this is called the solubility. The solubility of AgCl, how much actually does dissolve, is the amount that I get of ions in this one-to-one stoichiometric relationship. Sometimes the solubility isn't simply solving for one of your ions. If the stoichiometry is not one-to-one, you have to be very careful. But the solubility is not the 1.8 times 10 to the minus 10. That's a common mistake that students make. The solubility is how much does dissolve. The solubility product constant is my KSP numerical value. It's my equilibrium constant.